Now let's continue with the bus bars. So the bus bars, they are thick copper bars that will carry current from one point to another point. So of course, since they are very thick, we will consider that their resistance is negligible, and we will take only their impedance, which is equal to 0.15 milliohm per meter. So according to the length of the bus bar, we will calculate its total impedance. For circuit conductors or any wire or any conductor, the resistance value will be equal R is equal to the resistivity of the material over the cross-section area times the length. So of course the resistivity will be determined according to the material that we are using. So even it is copper or aluminum. So copper will be using 22.5 milliohm per meter square over meter, and for aluminum it is 36 milliohm per meter square over meter. So of course, to get the value of the resistance, we'll take rho over the cross-section area, which is in square millimeter, times the length, which is of course here in meters. And we'll consider that x, as we have seen that, so x is equal to 0 for circuit for cross-section areas which are lower than 50 square millimeter, and x is equal to 0.08 milliohm per meter for cross-section areas which are higher than 50 square millimeter. So now what should you do for next time? So for next time you should take this TD3, which is on your e-learning platform, and for each value or for each element you should calculate its equivalent part. So for the medium voltage network, for the transformer, for this cable, so please pay attention that for this cable it is made of four single, so we have different single core cables, 5 meter each, and each phase, so let's look at this indication, 4 times 240 millimeters square per phase. So it means that each phase is made of 4 conductors. So we have in total for the 3 phases 4 times 3, it means 12 conductors. So we are using for each phase 4 conductors. So this means that the value of the resistance will be divided by 4 because we will be having 4 conductors in parallel. However, the value of the impedance will not change. It will not be divided by 4. Of course, we'll be having here a main circuit breaker, a bus bar of 10 meters length. We have here another circuit breaker, another cable right here. Here we don't have any bus bar because we don't have any indication, and we have here a circuit breaker. So always we are interested in calculating, and of course this cable which is here, it is the cable which is after the circuit breaker. And whenever we are, so in this example we are studying this circuit breaker which is here. Whenever we are studying this circuit breaker, we will take directly the short circuit current that may happen directly after the circuit breaker. So we will not take into consideration the 3 core cables, the last one that they have indicated to us. So what you need to do, you need to dress a table and to write the value of R and write the value of X for each element. So of course, each element of what we have talked today about, they are all in series, and you know that you cannot add the value of R and the value of X. So what you will be doing, you will be getting the summation of R and the summation of X, and then of course ZT, which is the total impedance, will be equal to square root of the summation of R square plus the summation of X square. So please try to do TD3 and we will correct it next time.